In recent years, researchers have seen an alarming warming trend in the global climate. Reports of increasing temperatures, thinning glaciers, and rising sea levels have led to widespread speculation that global warming is being caused by greenhouse gases that result from man's activities. Climate models that predict the Earth's future climate patterns indicate that global warming could continue to increase if the concentration of greenhouse gases in the atmosphere continues to rise. Even though these climate models are powerful tools in predicting future global climate, a more detailed understanding of clouds and aerosols could lead to more accurate climate prediction models. Researchers may be able to determine why the climate is warming,
if it is being affected by greenhouse gases,
and what we can do to change it. That is why researchers at NASA are preparing 6 innovative satellite systems, which, when launched, will provide key information about the Earth's atmosphere. 2 of these satellites, Calypso and CloudSat, will focus primarily on aerosols and cloud structures, providing much more information about how clouds and aerosols interact with each other and how they're affecting the atmosphere's radiation balance. I spoke with Lamont Poole at NASA Langley Research Center to find out more.
It's important to study clouds and airborne particles, which we call aerosols, because both of them have significant effects on the Earth's climate, just like greenhouse gases such as carbon dioxide. But unlike greenhouse gases, which warm the planet, airborne particles and clouds can either have a warming effect or a cooling effect, depending on their type and their altitude. Because of these complicating factors, it's very difficult to represent cloud and aerosol processes accurately in climate models that are used to forecast the climate in the future. So the data that we will be collecting from CloudSat and Calypso will provide a much more accurate picture of cloud and aerosol processes.
So what are the differences between the Calypso and CloudSat satellites?
They're going to be launched on the same rocket, and when they get to altitude, they will separate into different but very closely matched orbits. In fact, as Calypso and CloudSat orbit the Earth, they will be within 10 to 15 seconds of each other in their orbit. CloudSat and Calypso are going to be flying as part of a formation of satellites that's called the Afternoon Constellation, or the A-Train for short.
The A-Train will actually consist of six separate satellites flying in close proximity to one another. Once in orbit, each satellite will cross the equator within minutes of one another. Once these systems are in place, what do you hope the outcome will be?
Our ultimate goal is to provide accurate scientific information to decision makers and governments worldwide. So that informed and balanced decisions on how to mitigate or adapt to climate change can be made. And NASA is going to play a very crucial role in this.